Okay, geometry 3-3 practice A. We skipped one problem, which is the proof, number 6. We're not going to do the proof on number 6. Find the value of x that makes s parallel to t and explain your reasoning. So this was the section where we were like, if we can make the, in this case, they are alternate exterior angles. If we can set these equal to each other and find the value of x that'll make them the same measure, then by the alternate exterior angles converse, we can conclude that s and t are parallel. So I'm setting those equal to each other, and then I'm just going to distribute 2 times x plus 2 times 10 is equal to 3 times x minus 3 times 8, which is going to give me 24. So I'm just simplifying on the left and simplifying on the right. There's nothing more I can do to simplify this, so I'm going to start undoing. I'm moving the 2 x's to the right-hand side by subtracting, getting x minus 24 is equal to 20 on the left. And so if I add 24 to both sides, what I'm finding is as long as I put in x is 24, I'm going to be able to show that s and t are parallel. And let me just go back and do the math up here. If it is 44. Thank you. That's funny. As soon as I just looked back at it, I was like, that's not right. Yeah, it's 44. 20 plus 24. So then I go back in, and if I can plug in, I want to make sure that these measures are equal. So I'm just going to go into my calculator and do 3 times the quantity 44 minus 8. That's putting that angle at 108 degrees. And as long as I'm putting that angle at 108 degrees, let's see, 2 times the quantity 44 plus 10, that's 108 degrees. So because the value of x being 44 makes those equal to each other, then I can say that as long as if x is equal to 44, s is parallel to t by the alternate exterior angles converse. Alternate exterior angles converse. So doing all the algebra is getting us the measure. This statement, though, is saying like what the conclusion is that we can draw. Make sure that your documents reflect that. You can use this on your quiz tomorrow as examples of how you want to present your thinking. Now, number 2, when I look at how these two are set up, this is giving me some consecutive interiors. And what I know about consecutive interiors is that, and especially I'm trying to prove parallel lines, if I've got consecutive interiors, that if they add to 180 degrees, then the lines there in between are parallel. So if 4x minus 12 plus 120, and I'm gonna approach this just a hair different. I've been mentioning these different strategies. If 4x minus 112 plus 120 is 180, if I just think about taking out that 120 degrees, what I know is that if this corner is 120, then the 4x minus 12 has got to be equal to 60. If this is 120, this corner is going to have to equal 60. So I'm just simplifying the problem a little bit more when I start to do my algebra. And you'll get at the exact same answer if you combine like terms before you started to do this. With my approach, go ahead. I took 120, 180 minus 120 and said, well, if these have to be supplements, then this one's going to have to be equal to 60. All consecutive interior angles are supplements, yep. Yep. All the rest of the angle comparisons that we had were all congruent to each other. This is the one that you have to remember winds up being supplements. Just finishing up my solving here and finding out that as long as x is 18, now let me go in and check. 4 times 18 minus 12, better be that 60, sure. As long as, so now I say if x is equal to 18, s is parallel to t by the corresponding angles converse. So that's what this explain your reasoning looks like. That's what the explain your reasoning looks like. As long as I plug that value in for x, I'm going to have what I need. I'm going to go on to number 3 here in a second. I'm going to sharpen some pencils first. X is 18, s is parallel to t. My parallel lines look funny. I should have made that one on the right a little bit longer. Sorry. Now, just looking at the next 2 problems. Is there enough information to prove? This is all about, well, if we know that angles are congruent, all these theorems were the converses. When I look at these 2 angles right here, these guys are corresponding angles. And what I know is I can decide if there's enough information. Yeah, sure, P is parallel to Q in number 3 by the corresponding angles converse. If we have corresponding angles that are equal to each other or congruent to each other, then the lines that they're on are parallel. The corresponding angles converse. So I look at the relationship between the angles, see if I can put a name to it, and then is it one of those 3 congruent formulas or congruent converses that we got out of section 3.3. In number 4, when I look at the angle relationships here, there isn't, this angle doesn't correspond to this one. This is exterior, this is interior. In this case, my answer is I don't have enough information to prove that those angles are congruent, or those lines are parallel, because my congruent marks aren't in any of those 3 relationships that we know that if the angles are congruent, the lines are parallel. The relationships that would make that true is us seeing alternate interior angles congruent, alternate exteriors congruent, and corresponding angles congruent. Those are the only 3, and I don't have that here. We had talked in our 3.3 notes about vertical angles not giving us any assistance in regards to proving lines are parallel. And so I think even Friday in class when we were working on this, I had made reference to a couple places. Where was it here? Oh, we had examples right here. So in our notes, in our extra practice on number 4 and number 5, in our pink notes extra practice, there's no angle relationships between the 2 lines I want to prove that are congruent to each other. So correct the error in the reasoning. I'm just going to, the error in the reasoning, I'm just going to explain that we can't conclude parallel lines based on vertical angles. We can't conclude parallel lines based on vertical angles. Make sure that you're clear about this argument. It will come up again. As the angles only relate to line N in this case, and we have no connection to line M. So there's no way we can prove both of those are parallel. Only relate to line N, and we have no connection to line M. Make sure that your arguments are sound and complete. This would be a perfect example of an argument how vertical angles don't make sense to prove parallelism. We can't conclude parallel lines based on vertical angles as the angles only relate to line N, and we have no connection to line M. Now I'm going to go on to, we skipped over the proof. We did not need to practice this proof for our work in chapter 3. Now, when I look at this, the angles formed between the braces and the wings of a biplane are shown in the figure. Are the top and bottom of the wings biplane parallel? And explain your reasoning. Well, I see these lines. I'm going to take let me just take a yellow marker. It'll stand out more. These are the lines they're talking about here. Are these lines parallel? They certainly don't seem like it, but we can't look at the way they seem. What we've got to focus on is their angles. And if they were parallel, how would these angles be related? What term do I put with these that are, and where they're positioned between these guys are alternate exterior angles. So what I could say is if the top and bottom wings of the biplane, again, I'm modeling the kind of response that I would expect to see on a quiz or a test. If the top and bottom wings of the biplane were parallel, the alternate exterior angles would be congruent, and they're not. I've got 145 degrees and 155. The alternate exterior angles would be congruent, and they're not.